Jenkins is an open source automation server. It is mature, battle tested, and familiar to many teams. With a massive plugin ecosystem, which can integrate with almost any SEM, build tools, test frameworks, or deployment targets that you already use. If you are serious about DevOps and platform engineering, understanding Jenkins on Kubernetes is a powerful skill that will serve you across many environments and teams. Hello everyone, welcome back to the channel. Today, we are going to learn how to deploy Jenkins on Kubernetes using Helm charts, configure Kubernetes-based agents, and run a real CI/CD pipelines. At a high level, Jenkins on Kubernetes operates within master agent architecture, where the master coordinates tasks and the agents execute them. Let us understand the key components. The first important part is the Jenkins master. This is the main Jenkins server that plans which jobs should run and manage all the plugins. When we run Jenkins on Kubernetes, the master itself runs as a pod inside the cluster. It stores our configuration and pipeline definitions, and it also talks to Kubernetes to request for new agents whenever a job needs to run. The second part is the Jenkins agent. These are the workers where the actual build steps runs. Instead of using fixed physical or virtual machines, our agents runs as Kubernetes pods. Jenkins creates these pods automatically based on the load. For example, if 3 jobs starts at the same time, Jenkins will create 3 agent pods. When the job finishes, those pods are deleted so they don't waste resources. The third part is the Kubernetes plugin. This plugin is the bridge between Jenkins and Kubernetes. It lets Jenkins talk to the Kubernetes API. With this plugin, we define pod templates that describe what an agent pod looks like, which container image to use, how much CPU and memory it gets, and which tool it should have for the build. The fourth part is persistent storage. Pods are temporary by design. To prevent data loss, we use Kubernetes persistent volumes to store Jenkins data. These volumes keep Jenkins configuration and pipeline logs safe even if the master pod is deleted and recreated. Let us understand the Jenkins Kubernetes workflow. The workflow includes the following steps. Jenkins master receives a job request from the pipeline. The Kubernetes plugin sends a request to Kubernetes for an agent pod. Kubernetes schedules the pod on a node in the cluster. The agent pod starts and connects to the Jenkins master. The build job runs inside the agent pod, and the pod terminates automatically and returns resources to the cluster after job completion. This cycle ensures that we always use resource efficiently. We only consume what we need and exactly when we need it, without keeping servers running continuously. As a prerequisite, we need a Kubernetes cluster up and running. In my case, I have installed Kubernetes version 1.35.0, which is the latest version as of this recording. And also, you need Helm installed and configured on your workstation. Once done, we're going to head to Artifact Hub, which is a web-based application that enables finding and installing cloud-native packages. Let us look for Jenkins and search. And we're going to use the official Jenkins. This page contains the information required to install and configure Jenkins on Kubernetes cluster. As a step 1, we are going to add the Jenkins Helm repository by using helm repo add command. Let's copy and run on our terminal. Once done, run helm repo update. We're going to fetch the default values.yaml file so that we can customize it based on our needs. We can do that by running helm show values command. I'm going to save this as jenkins-values.yaml. Once done, let me open the file using vim. This is the default values.yaml file, which we can customize based on our requirement. I will go ahead and change the admin password, which will be used to log in to our Jenkins UI. We can also install additional plugins. By default, this chart installs following 4 plugins: Kubernetes, Workflow Aggregator, Git, and Configuration as Code. If you want to install additional plugins, you can pass them as a list in the following field. We can also set custom message to our Jenkins UI in the Jenkins configuration script. Let's go ahead and uncomment the following lines. And you can customize based on your need. Let me go ahead and add a custom message. Let us go ahead and update the persistence field with a custom storage class, which would retain the data even if the Jenkins is deleted. Let us look for persistence, which is enabled by default. We need to have a storage class which will retain the data even if the deployment or the Jenkins is removed. Let me open another tab, and if I run kubectl get storage class, I have created a custom storage class called longhorn-jenkins, which has a reclaim policy of retain, and the volume binding mode is set to wait for first consumer. Let us go ahead and add this storage class. Also, we just need to make one small change in the message. In the config script, let us go ahead and remove the curly braces because we are using the welcome message. That's all. Let's go ahead and save and exit. Let us install Jenkins using Helm install command. I will call my release as Jenkins and pass the custom values.yaml file using --values and deploy it in a Jenkins namespace. Since the namespace doesn't exist, we will create it by passing the flag --create -namespace, and let me hit enter. We can monitor the deployment by running kubectl get pods -n the namespace, which is Jenkins -w. In the other tab, we can also run kubectl get events -n Jenkins to take a look at what's happening. It is currently provisioned the PVC. We can put a watch command, then we'll watch for every 5 seconds and run the kubectl get events -n Jenkins command. If we head back, it is currently creating the pods. Let me open another tab. We can also check the logs to ensure the installation is progressing as expected. We can run kubectl logs, then the pod name, which is Jenkins 0, then the namespace, and we're going to check the logs for the init container, and we follow it. This would give you the detailed information about what exactly happening during the installation. It is currently trying to download and install plugins. We can open another tab, and we can also run kubectl describe pod Jenkins -0 -n Jenkins, and the container created and the container started. The pods are in running state now. If we go back to the logs, when you see finished initialization, the pods will be up and running. Let us go ahead and access the Jenkins UI. Let us run kubectl get svc in the namespace Jenkins. We have two services, one called Jenkins, the other one is Jenkins agent. Since the service type is cluster IP, we can use the port forward to access our Jenkins. I will run kubectl port forward, then the name of the service, and use the local port 8080 to the container port 8080 in the namespace Jenkins. and hit enter. Let's head to a browser. We can access the UI by hitting localhost port 8080. And this is our Jenkins sign-in page. We can access using our default username, which is admin, and the password which we defined in our Helm values.yaml file. We also see the welcome message which we defined, Jenkins prod instance. If we go to the settings, we have different options where we can install plugins, we can configure our system settings, change the appearance, etc. When we deploy Jenkins on Kubernetes, it runs the agents as Kubernetes pods, which can be configured in the clouds section. We already have a Kubernetes configuration because when we deployed our Jenkins using Helm charts, it by default installed the Kubernetes plugin, which enabled this integration already. You can make changes to your cloud Kubernetes configuration in the following section, and you should also be able to create new configurations. To manage the plugins, we can head to the plugin section where you will be able to see already installed plugins. These are the plugins which are already installed on our instance. To install a new plugin, we can click on available plugin section. For example, let us install a plugin called Dark Theme. Select the plugin and click on install and check the box restart Jenkins when the installation is completed and no jobs are running. This would go ahead and install the Dark Theme plugin along with the extension and restarts the Jenkins. In order to use the Dark Theme, we need to set the Jenkins URL. Let us go to the settings. If we click on appearance again, we currently the Dark Theme present, but we cannot choose, and even if we choose and save, nothing happens. So what we can do is, let us go to the system, and if we scroll down, there is an option called Jenkins URL. In our case, it is on localhost 8080. Let us go ahead and update this to localhost and click on save. As soon as we hit save, the theme is applied. We can also go to the appearance and we can see it is dark. Let us build a simple Java application with Maven. We're going to use the following repository, which is part of Jenkins introductory tutorial. This repo contains a simple Java application which outputs the string hello world. The first step is to fork this repository. In order to do that, you have to have a GitHub account and logged in. Already logged into my GitHub account, and I will click on fork. And I will keep the repository name as simple Java Maven app and check the box, copy the master branch only, then click on create fork. We have a copy of the repository on our GitHub now. What we can do is we can clone the repository to local because we need to make changes to the Jenkins file. Let me click on clone. Let me head back to my terminal, navigate to mkbn GitHub repo, and I will clone my repo here using the git clone command. Once done, let me open the repo in VS Code. This repository contains a simple Java application, and it is accompanied by a couple of unit test cases to check that the main application works as expected. The result of these tests are saved to a JUnit XML report. It also contains a Jenkins directory, which has a Jenkins file. This Jenkins file has 3 stages: a build stage, a test stage, and a deliver stage. We are going to modify this pipeline script to make sure it works with our Kubernetes agents. Instead of agent any, we will define the exact pod spec so that it ensures the environment is identical every time the pipeline runs. We're creating a container called Maven with the image Maven 3.9.9. It runs a command. It runs a sleep command infinitely. And also I added a volume mount for /root.m2, which is the Maven cache. And I'm mounting the volume to an empty directory. But it is recommended to have a dedicated PVC, but this is fine for the demo purpose. Next, we must wrap our sh commands in a container Maven block. Let us go ahead and do that. Under steps, let us add container Maven, open a curly brace and close it. This would tell Jenkins to execute this command inside the Maven container rather than the default GNLP container. Let's do the same for our test and the deliver stage. Once done, we can save and push these changes to a remote origin. I'll open a terminal and run git status, which shows that we have modified the Jenkins file. We can go ahead and do git add, then the Jenkins file, and run the git status command again. And we can go ahead and commit this updated Jenkins file and do a git push origin master. Let's head back to our GitHub. If we refresh, we should have a new commit. And if we go to the Jenkins and the Jenkins file, we have our changes. Let's head back to Jenkins and create a pipeline to build this Java Maven app. On the left-hand side, click on New Item and enter a name. I will call this Simple Java Maven app and choose the pipeline and click on OK. We can add the same description. I will say Simple Java Maven app and scroll down. In the pipeline section, in the definition, we will choose the pipeline script from SEM and head back to our GitHub and copy the URL. Ensure that it is HTTPS. I will select the URL, head back to Jenkins again. Then in the SEM, we're going to choose as Git and paste our repository URL. Since this is a public repository, it does not require any credentials. In case if you're using a private repository, you need to create a credential and use it. And the branch is master in my case, and I leave it as it is. And if we scroll down, it is asking for the script path. Let's head back to our GitHub repository. If you take a look, the Jenkins file is inside a directory called Jenkins. So we need to define Jenkins/Jenkins file. Let's do that. I will say Jenkins/Jenkins file and click on apply and save. And this is the pipeline. Before we can run the pipeline, we need to install a plugin, which is Maven. Let us click on Manage Jenkins, go to Plugins and Available Plugins and search for Maven. The first one, which is Maven Integration, has a health score of 100. We're going to install this. Click on Install. The plugin installation is successful. We can head back to Jenkins homepage and we can directly run from here, or we can just go into the project and click on Build Now. And we can take a look at the progress. The console output shows that it is going to create a pod. So if we head back to our terminal and run kubectl get pods -n Jenkins, you can see it is creating a pod called simple Java Maven app, and looks like the container is creating. Once the pod is in running state, it would go ahead and execute the stages, which is build, test, and deliver. Now running the unit test and storing the test report. We have successfully built a Java application using Maven. We can also see the hello world. If we scroll up, on the left hand side, we can click on test, where you can see we had 2 test cases and all are passing. We can also click on the test report and take a look. On the left hand side, if you click on history, this will give you information about the build history. We had a single build which is passing 100%. I went ahead and installed a plugin called Blue Ocean, and if you open Blue Ocean, you will get this beautiful UI which show you the different stages from start to end. We had 3 stages: build, test, and deliver, which you can see all are passing. If you expand this, you should be able to see the console output for your build. You can click on exit to come out of the Blue Ocean. Let us build a Python application using Jenkins. I have another repository called simple Python app. And if you take a look at the app.py, this is a simple Flask application which prints a message hello from Python inside Kubernetes. Let us go ahead and copy the HTTPS URL, head back to our Jenkins and click on new item. I'll call this Python app and choose pipeline. Click on OK. We can leave the description empty. Scroll down in the pipeline section. Let me choose pipeline script from SEM and choose our SEM as Git and paste our repository URL. This is a public URL and our branch is main. So let's head back and change it to main. And the Jenkins file is in the directory Jenkins/Jenkins file. So let me update. Click on apply and save. We have created a new pipeline called Python app, which we can go ahead and click on build now. Before we can build the Python app, we need to install the plugin. We can go to available plugin and search for Python. And we have 2 plugins. One is Python and a Shining Panda. I've already installed a plugin. Let me show you which plugin. It's called PyEnv pipeline plugin. Go ahead and install the plugin. Let's head back to the pipeline. Open our Python app and click on build now. Let us take a look at the console, and it has created a new pod called Python app, and it has checked out our Git repository. It has installed our requirements. Then it has built our application, run the PyTest, and exported the result. Our pipeline is successful. We can scroll up and we can see it is passed, and we can click on test. We had a single test which is passing, and if you look at the history, we have a single build which is passing. In summary, when you combine Jenkins with Kubernetes, you get the best of both worlds: mature pipelines with dynamic scaling, strong isolation, resilience, and cloud-native operations. If you found this video helpful, please like, subscribe, and hit the notification bell for more Kubernetes and DevOps related tutorials. Thanks for watching. I will see you in the next one.